The next presentation we have is from Ron Sege. Ron Sege is the president and CEO of Echelon, an energy control networking company located here in the Bay Area. He has been the chairman of the board of directors of Echelon since October of 2011. Most recently, he served as the president and chief operating officer of 3Com, another technology company, all the way through its acquisition by HP. Prior to 3Com, Mr. Sege was the president and CEO of Tropos Networks. He's also held very high executive positions in companies such as Elakova Networks and Lycos. He has a bachelor's degree from Pomona College and an MBA from Harvard University. Please welcome Ron Sege.
Thank you, Ami. Can you hear me? Yes. Okay. So I think I really am all that's standing between us and lunch? Yeah. So the good news is that when you're last in a series of presentations, everybody made your points already. So I will try to be brief. I should say that I also have a Nest thermostat, and I think it's fantastic. One of the side benefits of it is not well publicized by Nest, but at night when my wife and I are asleep and I wake up, without getting out of bed, I can turn the heat down. And then when she wakes up and I'm asleep, she turns the heat up without getting out of bed. So we have a little hysteresis going on. So anyway, I'm a technologist, and I've been in this industry for only a couple of years. And I really only want to make one fundamental point, because I think many of the other points have been made about the potential benefits of smart cities and smart grids and so on, all the technology opportunities, et cetera. My point is that many of the impediments that we face in realizing smart cities and smart grids from a technology perspective are not really technological. They're regulatory and standards and that kind of thing. And I come from the perspective of starting my career in the analog telephony business as it was transitioning from analog to digital in the early 80s to the late 80s at a pioneering company here in the Valley called Rome Corporation. And then I went to 3Com in the late 80s and watched and helped the whole networking craze happen and Ethernet become the global standard. So the transition from analog telephony to digital in the enterprise took about 6 years. The transition from Ethernet being a little-known technology in the late 80s to it being a household name in the mid to late 90s also took about 10 years. We've been working on smart electricity and smart grid technologies at Echelon alone since 1988. In 1988, Mike Markkula, who was the first CEO of Apple Computer, had a vision of, gee, if we can connect wide area devices together, local area devices together, why can't we connect every electrically operated device together and have it communicate its status, how much energy it's consuming, so on, peer-to-peer, resiliently and reliably, and thereby improve comfort, manage consumption of electricity, and so on and so forth. So from 1988 until today, we've been building on that technological vision. LawnWorks is the name of our underlying technology. It's been open standard since the early 90s. We started in the building automation business. We then moved to the smart grid business. And most recently, we have been powering applications in the smart city business. Here are some of our projects. Our technology underpins the 30 million smart meter deployment by Enel in Italy. That project was completed in 4 years. And not only did it pay itself back as a result of lower theft of electricity, automated meter reading, but also in the pinpointing of outages and the faster dispatch to resolving problems. We automated the Louvre in 2000. So LawnWorks underpins the security system and the environmental control system for the Louvre. We were instrumental in building the lighting system for the Tour Eiffel. And all of these are open and standard systems that are operating today. We also are deployed in one or two of the demonstration projects in the Paris street lighting program as well. So the point, one of the points that has already been made is it's hard to build a 21st century city if you have a 20th century electricity grid. In the United States, I've read that the average power transformer is 40 years old. And around the world, I don't think the situation is much different. As a consequence of that, as was mentioned, we still have 1.4 million people without power on the eastern seaboard as a result of Hurricane Sandy. And in many cases, we don't even know where those power outages are. In fact, it was reported in the MIT Technology Review that Pepco, a utility in Washington, D.C., was able to use its smart metering system to pinpoint problems on the electricity grid, as if that was a new technical capability. The reality is it's not a new technical capability. That technology has been around for 10 or 15 years. It's a new deployment of old technology, and it's a new enablement of old technology. And it's only unfortunate that it's reported as state-of-the-art when really it's not. We talked about Fukushima and the disaster as a result of the tsunami and the ongoing issue of the demand for electricity in Japan exceeding the supply by 10 to 20%, and the same problem in China. Japan is finally getting around now to thinking about how to implement automated demand management systems, frankly, with technology that's been around for 10 or 15 years and it is deployed in places like Italy. China has the same problem. In many countries in the world, the biggest source of electricity loss is theft. And as a consequence, we have shortages, and people are paying more for electricity than they should. And even here in the United States, where the recession has resulted in less aggregate demand for electricity, or more aggregate demand for less than there is supply, we have spot shortages because of ever-increasing peak loads, primarily as a result of air conditioning. Those peaks could be managed automatically if we could just deploy the technology that is currently available today. And we can imagine an electricity grid in the future that has these characteristics, that is aware of its instantaneous demand, that's aware of its available supply, that's aware of problems and potential problems, that can be managed centrally but has no central point of failure, and where utilities can move from being commodity suppliers of electricity to being service providers for street lighting, for building air conditioning, and so on and so forth. We can imagine this world in the future, and in reality, we've already built it, and it's called the Internet. So this large-scale system, from a situational awareness, from a communication and a control perspective, already exists, and it was built starting 10 or 15 years ago. So my point is the technology exists for much of this. Yes, there are issues, there are security problems that we've got to resolve, just like there are on the Internet, but the fundamental technologies exist today. And by the way, as I've come to understand the challenges of cities and utilities and building owners, the problems we're trying to solve with the technology is all largely the same. We're trying to manage demands to balance demand and supply. We're trying to prevent outages, and when they happen, we're trying to respond to them quickly. We're trying to integrate in renewables, distributed and centralized. We're trying to reduce theft and technical losses and improve safety and lower prices. These problems are common among cities and utilities and building owners. As a consequence, my view is that we will start converging towards a common platform for managing all this, just as we've done with the internet. And this is one of the reasons I was so excited to hear about the platform vision and the platform strategy of the city of Paris, because the right answer is to build one platform that can deliver all these benefits. One platform based on technology that exists largely today. Today there's a fascination with deploying smart metering. Here in the United States, by the way, largely because smart meters were deemed to be a shovel-ready project by the Obama administration, and they wanted to get money into the economy as quickly as possible. So smart meters were deployed in some cases as a rush to judgment to get the devices out there to collect the money without a full consideration for the nature of the platform that a smart meter can underpin. So the good news is that many smart meters today are not just meter readers, they're also grid sensors that can identify the quality of power, the absence or presence of power, and so on, and as a result can participate in grid optimization programs and in the delivery of new services in the future. But again, the vision has to extend horizontally from the meter to all these other capabilities. So if technology isn't the problem, what are the major impediments from my perspective in deploying that which largely exists today? Well, one is stable government policies. Building the kind of technology that Echelon builds and selling it and deploying it in large scale is a 10-year proposition. So I've got to be able to invest with an understanding with my public company investors that we will deliver a return. In the United States, when public policy changes every few years, it's very difficult to make those long-term business decisions. Conversely, in China, where deploying a smart grid, for all the reasons I talked about, is a government imperative, primarily to balance supply and demand, the stability of policy is resulting in smart meters being rolled out in total to 300 million homes within 5 years. Europe has a similar vision with its 2020-20 mandate. Brazil has a similar one, but many countries do not. The second is simple, interoperable, global standards. The internet was largely architected by DARPA, with standards that were codified by the IEEE and the IETF. With deregulation in the United States, that was led by the FCC. There are no strong global standard settings bodies in the smart grid and in the smart cities. In fact, there are many country-wise and region-wise standard setting bodies that makes it very difficult for a small company like Echelon to build products that can be sold around the world. The third is incentives and fast tracking for experimentation. And I'm glad I was able to come to this great conference today because I'm hearing about a lot of the terrific experimentation that's going on around the world. But the fact is there are just not enough experiments and they're not being promoted aggressively enough. And then finally, you know, the free market in many respects drives innovation more than a tightly controlled market. So deregulation, as happened in telecommunications, I believe is positive for smart energy as well. So we're doing experimentation as well, or our customers are. I won't belabor these because you've heard many of them already. We've got lots of smart street lighting experiments going on around the world. In fact, street lighting consumes more energy for a typical mayor than any other project that they can automate and improve the capabilities of. We're doing home energy management projects like this one in Denmark, where we're actually delivering real-time information on how much it is costing you to run your air conditioner, your pool pump, and so on at a given point in time, so you can adjust your behavior accordingly. We're doing with Fordham in Finland a project on electric vehicle integration, where the electric charger is communicating with the grid and optimizing its charging times to ensure that we're not taxing the grid and its components with too much demand at a given point in time, for example, at 6 o'clock at night. And then I mentioned this PEPCO benefit associated with smart meters. This is something that should be standard everywhere there's a smart meter installation, but unfortunately is still today largely the exception. So yes, there's technical problems to solve, but in my view, many of the issues we face are regulatory and standards related as opposed to technological. So thank you very much.